Hey everybody, Mr. Calbeck here. This is going to be one more crazy angle lesson here in circles, and we'll be looking at even more kinds of angles. We talked about central angles in the first lesson, and then we talked about inscribed angles last lesson. These are angles that don't fit into either of these categories. If I'm looking at this circle right here at angle 1 and angle 2, center of the circle is right here. Angle 1 and angle 2 are not inscribed because they're not on the edge and they're not in the center. So what the heck is going there? They don't have a name as far as I know, but they're formed by intersecting chords. So the angles formed by intersecting chords, you look at angles 1 and angle 2. And we're going to talk about those today along with some other ones. So let's jump in and see how you guys do with this. There's a few more things to write down, so make sure you take notes today. Take your headphones out, turn the TV off, and hide your phone under your bed so you can't hear it buzzing, so that you can focus on this today, as it'll be a little bit more complex than the last couple because we just have more things to learn. All right, so we'll start with this one right here. How the heck do you find angles 1 and angle 2? I'm going to tell you right now, it has to do with the arc measures. All right, and you can see all these theorems written out for you on page 563 in Big Ideas. Again, if you are watching along and you are not using Big Ideas, then just go ahead and copy the theorems because I'm going to write them down for you anyway. But if we're looking at angle 1 and angle 2, all right, angle 1 and angle 2 are going to be, first of all, they're vertical angles. So we know that they're equal. So it actually doesn't matter which side of the intersection that you're looking at. Either side is going to give you the same exact measure. And the way that you find these is a little bit weird, but you have to know the arc measures. Okay, so we could take a look here. We'll call this A, B, C, and D, these vertices right here. If I want to find the angles, all I need to do is average these two arcs. Okay, so what I would say is angle 1 is going to be equal to the measure of arc AB plus the measure of arc DC. Okay, see again the two arcs, and I'm just going to divide that by 2. And that's it. Probably should put a little m here because we're talking about the measure of angle 1. Another way that you'll see this written in some textbooks is, and this is the way that Big Ideas actually writes it, it's the same thing, it's just written differently. The measure of angle 1 is equal to 1/2 times the measure of AB plus the measure of DC. Okay. Again, dividing by 2 and multiplying by 1/2 are the same thing. So if you're looking at that, that's the same deal. So all you have to do is actually average them. If you were to look at these other two angles here, so we could look at angle 3 and angle 4, I would just average the different arcs, the arcs that correspond with these angles. If we look at angle 3, it kind of makes this arc right here. So I'm going to average that arc as well as this arc over here. So if I wanted to do the measure of angle 3, it's going to be the same deal. It's just the different arcs, AD and BC. Wow, 1/2 times. And again, that's the same as dividing by 2 if you like that better. I personally prefer this one. I think it makes a little bit more sense to me in my mind rather than multiplying by 1/2, but it doesn't really matter which one you use. So the measure of angle 3 is going to be the average of the measure of arc AD plus the measure of arc BC. And that's as complicated as it gets. Okay. It looks a little bit weird. We're not going to talk about, just because we're talking about distance learning here, I'm not going to derive this or show you why it's true. I'm going to ask you to trust me on this one for the sake of time. But it is something to remember. So take a look at these. Again, it's all the same formula. You don't have to write all 3 down. Just needed to know one of them. Okay, so that's the first thing that we're going to be talking about. So angles inside a circle from intersecting chords. Remember, a chord is just a line that's not a diameter. that goes through the circle and stops on the edge. We call it a secant if it goes through and has arrows on the edge. But if it stops, we call it a chord. Okay? So we're talking about intersecting chords here. Oops. Okay, so intersection of chords. So let's look at some other ones here that we're going to try here. What happens, and this is going to be kind of weird, if I have a circle, and try not to get too freaked out, but what if I have the angle outside the circle? Okay. We'll go ahead and give these some letters here. DOPE, that looks good. And we're going to go ahead and talk about this angle right here. You can call that, I think in the book they called this angle 3. Again, it's also on page 563 if you want to take a look at this. That's fine. So how the heck do I find angle 3? It's not even inside the circle anymore. But it is related to the circle, so we can actually still figure it out. This is very, very similar to what you saw last time, or in the intersecting chords. Okay, these would be intersecting secants. Okay, again, secants go through the circle; they don't stop. So these are two secants. If I want to find this angle, angle 3, it's formed by the same two arcs. Notice that the angles make an arc here. They also make an arc here. It's the same idea, except instead of adding the two arcs, we subtract them. Okay, so I'm going to say the measure of angle 3 is going to equal arc OP minus arc DE. Okay, and just like last time, we're going to divide that by 2. Okay, so it's really, really similar. If it's inside the circle, we add them and divide by 2. If it's outside the circle, we subtract them and divide by 2. If you end up with a negative number here, you probably just need to switch which one you subtracted. Okay, you should always have a positive number when we're looking at angles. Negative angles are a thing, but not really in geometry, and you don't need to worry about that. Once you get to trig, algebra 2, pre-calculus, you can have negative angles, but we're not really going to talk about that here. This has got to be a positive number. So if you end up with negative, you know you got them backwards. Just switch whatever you're subtracting there so that it's positive. Okay, because again, a negative angle, it does make sense mathematically, but it doesn't make sense in any sort of real life situation where we talk about like an actual circle and an actual angle. You're not going to have a negative angle there. Okay. So those are the two basic theorems that we're going to be looking at today. Everything else, just like last time, is going to be based off of these two. Okay, so there's a couple of additional features we're going to talk about. Let's look at this first one here, and we're going to see what else we can determine from this one. All right, so let's look at the first one here. And I want you to see, what do you think would happen? Yeah, sorry, let's get this out of the way here. If I had an angle made this way, we've got a secant and then a chord. Actually, sorry, let's try this again. Tangent. Remember, tangent touches at exactly one place. What do you think would happen with 2 and 1 here? So this is going to be a little bit of an application we talked about from before. So this is going to kind of combine a couple things that we're looking at today. So press pause and see what you can come up with on what you think this would mean. All right. Hopefully you figured this one out. I'm going to go ahead and put some letters in here. But if I want to find angle 1, What you have to realize here is that last time we talked about inscribed angles. Remember, inscribed angles are going to be half of the arc. This is actually a ninja inscribed angle. Okay, normally we'd see like an angle like this, but since this is a tangent here, it's still technically an inscribed angle. So angle 1 is just half of AB equals 1/2 of arc AB. Okay, measure of arc AB. Jeez, stupid M. I always forget that. So there's a one trick one. So it's kind of a combination of last one and today. So if you have a tangent and a chord that goes through it, it's going to be half just because it's the same. It counts as an inscribed angle. Angle 2 right here would be half of this whole arc there. All right. So that's the first one. Now let's see if we can come up with some other examples here on what this would look like. Okay, how about another one here? Let's look at this. Two more tangents. Okay, and I'm going to go ahead and we're going to take a look here. I just need to get a quick example for this one. I'm going to say that this arc measure here is 125. And you've got to find x. Press pause. This one's tricky. It's an application of what we just did. Okay, it's another application, another connection to this formula right here, where you take these two, subtract them, divide by 2. You can use that to figure out angle x on this one. It's a little trickier, but I want you to see if you can figure it out. Press pause. All right, hopefully you're back and you figured it out. So I know that this arc right here, 125. So then the question is, how can I find x? I don't know anything else. But we do know something else. Since this is a tangent, it only touches at one place, you can actually figure out this angle over here as well, this arc. It's got to be 360 minus 125. All right, all we got to do to figure out this one, 360 minus 125. So that means this whole thing is 235 over here. And now we can use the formula. We have the two angle measures. I've got this one here and the bigger one. I subtract them, divide by 2, and it gives you x. All right, so let's try it. 235 minus 125, divide by 2. Let's see what you come up with. 235 minus 125 is 110. Divide by 2 is 55 degrees. So x is 55 degrees. Okay, so that's how we would do this. This is an application of that theorem. Again, it looks a little different, but it's the same idea. When you have an angle that's outside, you're going to be talking about subtracting these two angle or the arc measures and dividing by 2. Okay, and that's what we're looking at here. Okay, let's go ahead and try another one here. Hold on a second. Okay, go ahead and see if you can figure out or this first one here. This comes from page 563 if you want to go ahead and try them in the book, or you could just copy these down. We need to see if you can find angle y. Give it a shot right now. Press pause and take your headphones out. All right, hopefully you guys were able to come up with this. It's a little bit tricky, but we have to think about what we know about intersecting chord angles. Okay, and just like any other angle puzzle, I want to write down everything that I know. It might be useful, it might not be, but I'm going to write it down. Right, the first thing that I know, if this angle right here is 102, is that this has got to be 102 because it's vertical angles. That's 102. That means that this one has to be 78 degrees so that they're supplementary. So I'm just going to write all those in. I may need them, I may not, but I'm going to see if I can figure it out. Okay. Now the next thing I know is that the chords, intersecting chords, whatever this angle is always going to be the arcs that make it up, the average of them. Okay, so let's see if we can plug in the pieces. Remember those intersecting chords. So I know that this is 78 degrees has got to equal these two added up divided by 2. So let's try that. Y plus 95 divided by 2. Got an Algebra 1 problem right here. We can do it. Okay, just have to do the opposite. The opposite of dividing by 2 is multiplying by 2. We're going to multiply by 2 on both sides. Multiplying by 2 is going to give me 156 equals y plus 95. And now we have a 6th grade math problem. Subtract 95 from both sides and you get y. 156 minus 95 means that y has to be equal to 61. Okay? And again, try not to get tripped up with this. I know it's a little weird, but fill in the pieces. Remember, you know that the average of these is equal to the angles. So plug in what you know. If you know angle 1, plug it in. If you know the measure of one of the arcs, plug it in. If you don't know the measure of one of the angles, just go ahead and leave it as a variable. That's fine. And then you can solve. You're never going to have more than one variable in a geometry math problem unless you have 2 equations to solve for it. Okay? And you're not having 2 equations here. All right? This is your next problem. Go ahead and press pause and try this one. Oh, what's this down here at the bottom? Who wrote peasant? Who would write peasant on a video that Calbeck's doing? Gosh, stop that. Oh, you can still see it. Okay. Go ahead and see if you can solve for A. See what you can come up with. Again, same idea, but this is an angle outside that we're looking at. We're trying to find the arc measure of A. All right, I hope you guys tried that. Good luck, and I hope that you noticed that the letters spelled Calbeck on this one. No big deal. Letters down here spelled peasant, so that worked out. So we've got Calbeck. Remember that the arc, or that the angle, is going to equal the big arc minus the small arc divided by 2. So the big arc is A, minus the small arc is 44, divided by 2. Let's solve it. Again, this is an Algebra 1 problem. First thing we're going to do, multiply by 2 just like last time. That's going to give me 60 degrees. Okay, equals A minus 44. If I want to get A by itself, I just need to add 44 to both sides. And if I add 44 to both sides, hopefully you can do that in your head. But if not, A is going to equal 104 degrees. Okay, I should put this degrees too. So yeah, A is 104 degrees. Again, this is kind of the sort of problem that you're going to see. You have to apply what you have seen and go ahead and plug it in. All right, there's one more theorem I'm going to teach you guys, and then I'm going to set you loose on your homework. All right, so last theorem for today. This is called the circumscribed angle theorem. So this is going to be really similar to one of those last problems we just did. But if I have an angle outside a circle and it makes 2 tangents like this, okay, and we can call them whatever you want. Okay, so A and B, C over here. All right, and if I have a center of this circle, call it X. If I make an angle in this, a central angle, right here. All right, so notice here that the angle out here and the central angle seem to be the same arcs. I've got this arc here that's a part of angle C as well. So if I want to deal with this, here is how it works. Okay, The measure of this angle here, we can call it angle 1 for simplicity's sake. So the measure of angle 1 is going to be equal to 180 minus this central angle here that we'll call angle 2. All right. And I'm not going to talk about, again, where this comes from because we're talking about distance learning here. There's only so much time I have. And frankly, most of you guys turn me off after about 3 minutes anyways. So to spend another 20 minutes deriving this formula, I feel like is unnecessary. If you want to look it up, there are people that have done videos on why these theorems are true. However, this is one I just want you to learn. Okay, so you need to make sure that you understand the relationship between these, and you're going to have to kind of combine these. But remember, measure of angle 1, this outside angle formed by the two tangents, is just going to be 180 minus the central angle. Okay, it is related to those other angles that we are talking about. Okay, it has to do with that whole dividing by 2 thing. And again, we could derive this later, but for right now, I just want you to memorize this. All right. I'll give you one practice problem, and then I'll let you loose on the homework. Okay. So let's go ahead and try this. Actually, I'll give you 2 practice problems. Okay, I'll press pause while I draw them for you. You don't have to watch it. All right, so try these ones. They are this first one's pretty straightforward. The second one is tricky. It's going to apply a lot of different things that we've learned in this chapter. So don't be afraid to reach back into your toolkit and grab a couple of extra things that we learned about. Everything from central angles to inscribed angles. All 3 lessons will go into this one. This one's just this lesson. So give it a shot. Press pause. See what you can come up with. All right, let's see how you did. For angle x, remember angle x is going to equal 180 minus the central angle. I actually have all 3 pieces here. I'm just looking for x. I take 180 and subtract 120. And it's that simple. Recognizing this is the central angle, that's the outside angle. It's just 180 minus that. So that means that x has to be equal to 60 degrees. Okay, another way you could have found this if you didn't recognize it, you could have figured out that this right here, because of the central angle, this arc is going to be the same measure. This is 120, which means that this one has to be 360 minus 120. It's the rest of the circle. So this has to be 240. So another way you could have done this, apart from this formula, is to recognize, oh, well, I know that this is 120, this is 140. I subtract and take the average. Okay, so it would be 240 minus 120 divided by 2 to give you x as well, using the formulas we learned today. So you actually didn't even need to know this formula for that one. All right, and most formulas you can simplify this way as well. Actually, I did almost derive this. Dang it, I said I wasn't going to derive it, and I almost did. I love talking about why. The second one is trickier, but let's see what we can come up with here. Okay. So with this one, there's actually an angle here that you don't have that you need. It's this angle right here. The central angle I did not draw in for you. Okay. And if you notice that the outside points spell the letters noob, congratulations, they do. If you did that, this would be very helpful to draw those angles in. Again, if you don't have angles and you want to, draw them in. No big deal. Okay, so remember, if I wanted to find this angle right here, angle L, I could do the same thing. I know that angle L, it's that central angle, I would just put the variable in for this part of the formula. So I could find angle L this way. I'm just going to replace this with L and this with 50. And now I can solve. So it's going to be 50 minus, or equals 180 minus L. And I can solve this. That's going to be minus 180 minus 180. This is going to give me negative 130 equals negative L. There is a ninja 1 there. Don't lose your ninja 1s. To divide both sides by negative 1 to get L equals 130. Why does that help me? Because that means the central angle is 130. That means that this arc measure is also 130. And remember that inscribed angles are always half of the arc. So if this arc is 130, x has to be half of that, or 65. Okay, that's a tricky one. It uses everything we talked about. Central angles, inscribed angles, and exterior angles. All three kinds of angles that we've talked about are in this problem. And I think a lot of people get tripped up on stuff like this because they're afraid to dig into their toolbox and try something new. Try something that they haven't put together before. Please don't be afraid to put stuff together. It's not that scary to do. Don't be afraid to be creative. Math is all about being creative, particularly geometry. You have to be creative about how to solve things. They're always going to give you variables in a place you don't expect. So expand your horizons, explore a little bit, try to figure out how, in a creative way, you can find those missing variables. Don't be afraid to do that. It's really what we're trying to teach you. I don't care if you memorize this. You can look up formulas. What you can't do is know how to use formulas. That's the important thing. Can you be creative? Actually be posting a video later this week about how I use trigonometry to do my flooring. Okay, you guys have seen all the crazy stuff going on in my basement, but underneath all of it is a brand new floor that I put in, and I use trigonometry to be able to do that correctly. So get creative. Don't be afraid to dig into your toolbox and try something new and different. Okay, best of luck to all of you guys, and good luck on your homework.